All right, we've been doing a lot of review material. Let's get into some new things today. So today, first we'll look at 3.5, which again is more equations of linear functions. So far we know if we have the slope of a line and we know the y-intercept, it's pretty easy to write the equation of the line, y equals mx plus b. So if we know that a line has a slope of 3 and it has a y-intercept of say 0, 1, from that information, we can immediately write the equation of the line, y equals 3x plus 1, because 1 is the y-intercept. If instead we know the slope of the line at an arbitrary point, x1, y1, we can use this new formula to quickly come up with the equation of the line. And this is a slightly different technique than we used in Math 20, sorry, in Math 65. So in this case, again, m, of course, is the slope, which we're given as being 1/2. And in the formula, x1 and y1 are the coordinates of the given point. And so x1 would be the value 2, because that's the x-coordinate of our given point. And y1 will be the value -3, because that's the y-coordinate of our given point. And then in this formula, the plane x and the plane y are going to stay as letters. As we know, our final equation should have the letters x's and y's in there. So we can plug and chug. Y subtract y1 is -3 equals m, our slope, which is 1/2, times x subtract x1, and again x1 is 2. And then we simplify. So this would become y plus 3 equals, and I'll distribute here, so I'll get 1/2 x, and then 1/2 times the subtract 2 will give me a subtract 1. Then I can subtract the 3 from both sides, and that gives us our new equation, y equals 1/2 x, subtract 4. So that will be the equation of the line that has a slope of 1/2 and goes to the point 2, -3. If we know 2 points on the line, we can use the same formula, but we'll first have to use our slope formula, m equals y2 minus y1 over x2 minus x1, to first find the slope. Then we can use the slope in one of those 2 points, it doesn't matter which of the two, in our point slope formula to find the equation of the line. So to go through an example here, given 2 points, we first find the slope. So m equals y2, which is 6, subtract y1, which is -4, be sure to watch your signs there, divided by x2, which is our 2, subtract x1, which is our 7. So 6 subtract -4 is 6 plus 4, which is 10. 2 subtract 7 would be -5, and we know our slope is -2. Now we'll take this slope and one of the 2 points, whichever the 2 points looks easier to work with. I think I would grab the second point, the 2, 6, simply because it has both values positive, a little less complicated then. And then we'll use our new formula, y subtract y1 equals mx subtract x1. Our slope again is -2. x1 will be 2, and 6 will be our y1. So y subtract 6 equals our slope -2 times x subtract our x-coordinate 2. And then simplifying, y subtract 6 equals, distributing, we'll get -2x. -2 times -2 would be +4. We'll add 6 to both sides. And we get our new equation, y subtract 6. Sorry, we eliminated that. It will be simply y equals -2x plus 10. And that will be the equation of the line going through those 2 points. If we want to do a really quick and dirty graph, original points were 7, -4, which is about there, and 2, +6, about there. And doing a quick graph here, it looks pretty plausible that we could have a y-intercept of 2 and a slope of -2. Using a grid would give us a much better check, but that's not bad for a very crude quick check. Okay, got another example here, and let's go ahead and run through it. So first find the slope. y2 subtract y1 over x2 subtract x1. And again, if you find it helpful, go ahead, label these values. x1, y1, x2, y2. 3 subtract negative 7 would be 3 plus 7, which is 10. Negative 2 subtract 4 would be negative 6, and that would reduce down to negative 5/3. Once we have the slope, pick one of the 2 points to work with. It doesn't matter which one. I don't really have a preference here. Let's go with the first point, this one. So we're going to use the point 4, negative 7 as our x1, y1. And of course, this is our slope m. And the formula we're using is y subtract y1 equals mx subtract x1. A good way to memorize a formula is simply by writing it out a lot of times as you're doing your homework. So every time you use your formula, go ahead and write it out. And let's see, x1 was our 4. So simplifying, we've got y plus 7. Negative 5/3 times x is simply negative 5/3 times x. A negative times a negative will be a positive. 4 is the same thing as 4 over 1. To multiply fractions, we multiply tops, multiply bottoms. And so that's going to give us 20 over 3. So let's take a little bit of work here, because now we need to subtract the 7. And 7 would be the same thing as 21 over 3 to get a common denominator. And so that will give us y equals negative 5/3 x. 20 over 3 subtract 21 over 3 will give us negative 1 over 3. And then again, easy enough, we could pop this into our graphing calculator. And what we're looking for is, does it pass through the 2 original points? A couple special cases with our vertical and horizontal lines. And what I always find easiest when I'm coming up with these equations is simply to go ahead and make a graph and kind of visual. So the point negative 1, positive 4 would be around here. And I want a vertical line. So a vertical line straight up and down. On the vertical line, every single value of x here is negative 1. So my equation is simply x equals negative 1. If I want a horizontal line through that same point, with a horizontal line, every y-coordinate is equal to 4. So my equation is simply y equals 4. You can't get much simpler than that when it comes to writing a formula. Okay, this one's a little bit trickier, just because you got to think a little more. We're given a point, and rather than being told what the slope is, we're simply told it's parallel to this line. And then with this line, it's not in slope-intercept form. So we're going to have to first rewrite it. We can subtract 3x from both sides. What we're trying to do is get it into our standard slope-intercept form, y equals mx plus b. And once we're in that form, we can tell that our slope is negative 3. Because we want to be parallel, we're not going to change the slope. We want to use the same slope. And then we're given our point, and now we can go through our usual formula simplification. And there we go. Okay, so this next one, I'm going to have you do. So this will be one of several problems in this assignment that you're going to need to write up and bring to class next class period. So the equation of a line through this point and perpendicular to this line.